Good. Y'all tell me if Twitch starts getting mad. It might. It sometimes does. Okay, yeah, but at Costco. So, at Costco, there are two memberships. Two different type of memberships you can get. So here, let's see. Let me just... Costco memberships and prices. Yeah, here we go. This is old, actually. I think the new prices are $65 and $130. I think they just went up. But let's just assume we have the old prices. Okay. Yeah, exactly. Yeah. Because you buy like multiple things in like bulk. Okay. So at Costco, there's two memberships. Or two main ones. You don't really need to like deal with this. This is business stuff. 1 second. Let me turn this music down a little bit. A little loud. Okay. So this is just $60 up front. This one, you get 2% cash back on every purchase. So what that means is if you spend $100, for instance, you get $2 back the next year when you go to renew your membership. It costs more up front. So a good question here is like, how much do you need to spend at Costco in order for this to be worth it? Right? In order for the membership to be worth it. So, you know, let's think, right? We could say like, you know, the cost of a Gold Star membership, you have to spend $6K for it to be worth it? Well, let's see. Let's do the math. I'm glad you did that so quickly. So the cost of a Gold Star is just literally just $60, right? Doesn't matter how much you spend at Costco. It's always going to cost you $60. The cost of the executive, right? That's equal to $120 up front, but then it's minus 0.02 times X, right? Where this is the amount you spend. Okay? This is a good way of like taking, again, a real world situation, going to Costco, and seeing, wait a minute, how much money do I need to spend there for this to be worth it? So you could just set these equal to each other, right? So let's say the cost of this is equal to the cost of this. So that's 60 is equal to 120 minus 0.02x. We can move the 120 over here, so minus 120, minus 120. It's all about Sam's Club, Sib. I actually do like Sam's Club. We don't have them here in California. Or do we? Sam, I forget where you're from. But around Los Angeles, definitely no Sam's Clubs. One sec, let me turn on the chat. What's up? Gee, it's HHH. What's up, dog? Okay, so you get negative 60 is equal to negative 0.02x. So divide both sides by 0.02, by negative 0.02. And if you don't want to use a calculator here, remember that like 0.02 is the same thing as 2 over 100, right? So this is the same thing as 60 divided by 2 over 100, which is the same thing as 60 times 100 all over 2. So that's equal to 3,000. Yeah. Oh, you're in Riverside County until school starts. Oh, no way. Oh, Riverside has a Sam's Club? That's lit. Nice. Yeah. So $3,000 is the amount of money you need to spend at Costco in order for this membership to be equal to this membership. Okay. It turns out you actually get some additional benefits with this. Like, you can go to Costco earlier than other people. I forget what else they have, but yeah. Math, real world and math. Like this, I tell people you do use algebra for sure, like sometimes in the real world. So here's a good question. I got back, I just got my check back, and I got $139 back. So let's say this, right? Let's say like Dr. G got, I just spent it. I just spent the whole check. got $139 back. How much did he spend at Costco last year? How much did he spend at Costco? Okay. So we know that like cashback, right? So cashback is equal to 0.02, same thing as 2/100ths of what you spent, right? Good, exactly. So 139 is equal to 2 over 100x. Multiply by 100, divide by 2. It's actually kind of horrifying. So that's 13,900 divided by 2. So almost $7,000. Wow.
That's dope.
Costco's definitely getting their money's worth from me, bro. What? Okay, yeah. So apparently I spent close to $7,000 at Costco last year. And I mean, I understand why, because every time I go, dude, I don't walk out with less than $500 or $600 worth of stuff. I don't know, they just get me somehow. Imagine a family of 4, yeah. I mean, to be honest, I probably eat for a family of 2. It didn't used to be that bad. I mean, this is another comment on like the economy right now, because yeah, I used to probably spend about $300 or $400 at Costco, and then right after COVID, with whatever inflation and everything and all the prices going up, I started noticing it was always $500 or $600, and I was like, oh no. People are also likely to spend the cash back on Costco. Yeah, no, everything at Costco is a win-win for them, right? The gas is also super cheap. They sell the gas really cheaply because they know that also you're gonna be more likely to go in and, you know, buy things at Costco. Like, very rarely do I go to Costco and like just get gas and leave, or like just go get a hot dog and leave. The other big one is the rotisserie chicken. The rotisserie chicken at Costco is it's a lot of food, first off, and it's only like $6. It's so cheap. You can feed yourself like 3 or 4 times with a single rotisserie chicken, but it's all the way in the back of the Costco. So they make you walk past everything to go get that $6 chicken, and then you got to walk all the way back. And so what's the chances you're going to see something and buy something? Like, hell yeah, dude. Yeah, I would totally get something. I was at Costco today, and hilarious what they had. One sec. I got a video of it somewhere. Here. Look. Yeah, they had a Star Wars pinball machine at Costco. Look at this. This Star Wars pinball machine they had. This shit was dope. The only problem is that like this Star Wars pinball machine is $4,800. It's really expensive. Let me see. Star Wars pinball machine. Yeah. It was at Costco though, yeah. It was for sale. You could play on it. They let you play on it. It was just chilling there. Yeah, here it is. This is it. Yeah, okay. Okay, it's $5,000 online with delivery. But yeah, you could pick it up at the store for $4,800. How many calories do you eat a day, G? If I'm like watching what I eat and trying to cut, probably around 2,000, 2,100. Today I'll probably eat like 3,000 because I just don't care. I'm about to go to the desert for 2 weeks, and I'm starting to load up on food basically. How much are standalone arcade games these days? Like, to actually play one? I don't know. But if you want to go buy one at Costco, it's $5,000. Yeah, low-key, I'd rather spend $2,000 on a good PC than an arcade game. True. This is for a different audience, obviously, right? Pinball machines are a nostalgic thing for people that are older than me, honestly. my generation didn't really play pinball. It's like the generation after me, like the older one. Oh, not pinball, like Donkey. Oh, how much is a standard video game? Anywhere from $70 to $80. I'm pretty sure it's now $80 to buy video games. Like, let's see, how much is Black Ops 6 or Black Ops 7? Is that the new one coming out? Black Ops 7 is $70. They always do like some weird fucking edition for more, like $100. Yeah, I remember when video games used to be 50, 60. Now they're 70, 80. Oh, the stand-up arcade games. Oh, I don't know. You want like a Pac-Man? There are sales on Steam. True. Okay, here you go. I mean, you can get the small one here, yeah, for like $500. If you want this one from the website called the Man Cave Authority. I love that they call themselves the Man Cave Authority. Looking around $3,000 for like a full heavy duty one, yeah. Oh, bro, you can get the fucking Daytona set. You can get one of these for $13,000. This is nuts, though, dude, bro. Like, what? Big buck hunter, like, dude, stop. Also, what? $13,000 for this machine, dude? Stop. Excuse me. Oh, dude, but yeah, this would actually be pretty sick. 18,000. Okay. All right. Enough of me like looking at video games. I want to help you guys out with some questions. Oh, Red Dead Redemption 2 for 20. Now it's 120. Yeah, they do sales every once in a while. It's good to catch them. Okay. Let's see. We got any news today? Today's like the second to last stream for the month. Tomorrow will be the last one. And then after that, I have to go pack a big U-Haul trailer and go to Burning Man. So yeah. And then we'll be back streaming again in like September. So give me a little bit of a break to recover. But for now, we do got some good questions. Look, Dylan's got one. I like that, Dylan. Thank you. Dylan submitted this. Okay, cool. Any other news? Summer camp ended. I'll talk about the talent show that I'm going to have you guys submit to while I'm gone at Burning Man. And then we'll do the drawing for the Nintendo Switch when I get back. So like early September. So. Oh, also, yeah, we'll do a drawing tomorrow. If you haven't completed the survey yet, there's a survey on our announcements tab. I don't know if you've seen it yet. Let me go find it. One sec. Discord. Yeah. So if you go here under announcements, there's a link here for a Google form. If you fill this out, you get entered in to win a $20 gift card. And it's done by one of our friends, Stuart. He's doing I think for his master's thesis in like education, he's doing like a quick survey on tutoring on Twitch, and he's asking students if you take advantage of, again, things like we do here, like helping you guys out on a live stream, and how it could maybe be useful for other students. Good. You submitted a question? Okay, cool. All right, let's start off the stream. I'll help you guys out. Welcome everyone to Actual Education. My name is Dr. Gold. This is office hour stream that helps you out with math homework, science homework.
Oh, yeah.
Nice. All sorts of fun stuff. Let's see. First question here is from Dylan. Dylan, if you're in my chat, want to say hi? All good? You submitted... Yes, you did, HH. I'll get to yours as well. Yeah, you submitted a couple yesterday, didn't you? Yeah. I like that one. Yeah, look, I'll do the unpolarized light one for sure. I'll do that one. Okay. Okay, let's see. Let x and y be positive integers such that 1 over x plus 1 over y is equal to 1 over 20. What is the maximum possible value of y? Fascinating. Okay. Yeah, Jeff loves math. Jeff's like, we're doing math? Not doing what is it? Physics? One second, let me activate my chat on here. What's up, Dylan? Activate my source here real quick. TikTok always makes me like do some weird stuff here to verify my chat coming through. There we go. We got the little is that a warbler? What is that, a warbler? Okay, cool. All right, now we're good. Should have connected it. Okay, cool. All right. What is the maximum possible value of y? And they have to be integers. Wow. At this point, I feel like I want to try all of them. Like, I just want to try 1 over 480 and, like, see what I would need. Right? Oh, okay. So here, I think there's a pattern here. Yeah. Jeff kind of has it down. Yeah. So what we're gonna do is we're gonna combine these denominators first, and let me show like why this is the way it is. If for instance y was equal to 480, let's see what happens. So you have 1 over x. No, you're good, Sib. I appreciate the long and annoying ones. They teach me things. If we wanted these things to add up to this, right, we need to first like make this have the same denominator as this. So here, to get from 20 to 480, you need to multiply by, what is that, 24? So I believe this is 24 over 480. Okay. So then this would need to be 1 over x would need to be equal to, if we move this over, 23 over 480, okay? Which means x would equal 480 over 23. But that's not an integer. That's the thing. It has to be a positive integer. 480 is not divisible by 23. So this doesn't work.
No.
Okay, so, I mean, we at least showed, like, why one of the answers doesn't work. So this one is wrong. Let's see if there's maybe, like, a more intuitive way to do this. Jeff is saying, let's just, like, convert it to something first. Yeah, let's try that. Okay. Okay. If we were to combine these fractions, okay, so you have 1 over x plus 1 over y. Fractions suck, yeah. We don't like fractions. 1 over 20. Then, in order for these to have the same common denominator so that you can add them together, you have to multiply this by y over y. You have to multiply this by x over x. And then what you end up getting is y plus x all over y times x has to be equal to 1 over 20. Okay, cool. Or 20 times x plus y is equal to x times y. I feel like I want to come up, Jeff. I feel like I want to come up with a solution for what y would need. Sorry, for what x would need to be given y. Because then I think it'd be easy for me to just plug in values for y and just see what happens, right? Otherwise, I'm not sure intuitively I can see here what adds up and also multiplies. Exactly. Yeah, I agree with Shri J has the right idea. Yeah, I agree with that. You do know xy must be divisible by okay. But then I also don't know what like x plus y is. Yeah, this is a good way to think about it though. I like Shri J's idea of let's get what x would be in terms of y. Okay, so let's do. Ooh, I like this. Think of it like this. Maximum y would mean minimum of 1 over y, meaning the maximum of 1 over x. So we need 1 over x to be its max. Okay. Well, the maximum 1 over x can be is 20. Or sorry. The maximum x, yeah. This can be 1 over 20. If this was somehow like infinity. Right? 21 because it's positive. True. True. Let me see it this way. Okay, one sec. I'm gonna solve. I'm gonna solve for x in terms of y. So that's equal to 1 over y plus 1 over 20, which is the same thing as, yeah, look what we're going to get here, right? We're going to get 21 over 20y is equal to 1 over x. Oh, minus sign. Oh, oopsies. Sorry. I wanted the 21 to happen. I really did. Sorry. Negative 19. Right? Yeah. Negative 19 over 20y is equal to 1 over x. Yeah, so x is equal to negative 20y over 9. Yeah, that can't be correct. What did we do wrong here, dude? What? Oh, I know. I fucked up. Sorry. I'm skipping too many steps. Sorry. This is 20 over 20. This is y over y. Yeah. Okay. There you go. Sorry. Sorry. It's equal to negative 20, or let's say y minus 20 over 20y is equal to 1 over x. Sorry. I thought this was a 1. I was screwed up. Okay, so x is equal to 20y over y minus 20. Good. Yeah, I agree with that. Do we think there's an easier way to look at this? Like if I divide the top and bottom by y, then I would get like, what would this be? 20 over 1 minus 20 over y. That looks pretty cool, right? This is where I wish I knew more number theory, because I'm wondering if there's some rule here for this to be an integer. I mean, you can see right away, if we plug 40 in, so that's 1 minus 1 half, which is a half, and then 20 divided by a half is 40. So this one's okay. Yes, 1 minus 20 over y has to be a divisor of 20. Correct. So, I mean, this works, but I doubt it's at least 1. X equals 21. Y equals 420. Yeah, let's look at it. I just want to go through them real quick. Well, maybe we should start at the top, right? Because it's the maximum possible value. No. 1 minus 20 can't be less than 1. Oh, it can be less than 1, correct. So, if D was 420, then you have 20 over 1 minus 20 over 420, which is going to be, what was that, 1 over 21, right? 2 over 42 is 1 over 21. Okay, so then that's 21 over 21 minus 1 over 21. Cool. That's equal to 20 over 21. And then 20 divided by 20 over 21 is just equal to 21.
Good job.
Okay, so this is the correct answer. Wow, that's a cool one, Dylan. I like that.
Good job.
And A says too easy. I think that was good. Now, here's what's interesting. If we weren't given the answer choices to go through, could we have done it? Do you think we could have? Like, I agree it's easy when we're just plugging, chugging, like, what, but let's say they didn't give this to us. Is there an easier way? Is there a way to determine what that number is instead of just running that number up? Well, X has to be at least 21. I see. So that's the number to check. But what if 21 hadn't worked? So what, then I go check 22, go check 23? I like that, Dylan. Yeah. I'm just wondering, what if you didn't get lucky? Like, I don't know, say this was like 1 over like 60. Do I instantly just check 61? Yeah, like, I'm curious. What if instead the question was 1 over x plus 1 over y is equal to 1 over 60. It should work because, okay, Jeff's saying it should work because 1 over n minus 1 over n minus 1 equals 1 over integer. Okay. It works regardless? Okay. I just want to try. So let's say x equals 61, right? Yeah, I'm going to do it. 1 over 61 plus 1 over y is equal to 1 over 60. So then this is times y times 61 times 61. So I get y plus 61 over 61y equals 1 over 60. I think you want to actually move this over first, don't you? Yeah, I like that better, Jeff. Yeah, let's do that. Let's move this over first before I start doing things. 1 over 61 minus 1 over 60 is equal to negative 1 over... Other way. He says do it the other way. Okay, all right, my bad, sorry. Wait. What happened to the y? Oh, okay. I see what you're saying. Sorry. 1 over y is equal to it's 60 minus 61, right? Or no. 61 minus 60 over 61 times 60, right? Yeah, there you go. Okay. Nice. Okay, then let me get my calculator out. Well, 60 minus 61 is just 1. What is that? 36, 90, 36, 61? Ooh, NA says it's x equals 63, though. Because, yeah, 61 times 60 is 3660. So that tells me y is equal to 3660. I think this one works, though. Or don't forget the t. Don't care about the t. So wait, does 1 over 61 plus 1 over 3660 equal... Or actually, we just erase all this. Equal 1 over 60? One divided by... I'm going to show the calculator to you guys. I do believe that is 1 over 60. Yeah. Yeah. Very interesting. Okay, cool. Yeah, NA, so I think this is the pair for this one. You're right, 63 and 1260 probably works. 1 over 63 plus 1 over 1260. Yeah, that works as well, but it's not the highest one, right? Okay, cool. That's a cool question, Dylan. Appreciate it, dude. Jeff says, I think you can show making x 1 bigger than the right side denominator always works. Yeah, no. Thanks for the question, Dylan. I'm sure some of our users or other viewers... We're streaming also on, like, TikTok and... you're on TikTok. We're also streaming on Twitch and YouTube. That's why there's another chat. I need to figure out how to get those chats onto TikTok. I can get the TikTok chat onto Twitch and YouTube, but TikTok's, like, they're finicky sharing their stuff. Now, if it was 7 over 60, that might be more interesting. Yeah. Edenrot says, Dylan, migrate to Twitch, bro. You won't regret it. Okay. Nice. Okay, cool. Good question. I liked that. Yeah, if we have time, we can try to do it, like, algebraically.
Well done! Well done!
Yeah, that stuff is tricky, right? It messes me up, Sib. Totally. Why can't I copy his image in? I took like a 10-minute nap before this stream. I was helping, so there's this kind of older gentleman at the gym. He's 92. And bro's like still like, I don't know, he's still like benching at least like a plate. He's nuts, dude, this guy. And he has like all these stories. He's like one of these, I find as like people get older, if you start talking to them, they won't stop talking to you. And, you know, I know that as you get older, you probably lose people to talk to, so you kind of grasp onto anyone who will listen to you. So I will just like sit there and just like listen to like people just talk to me about their lives and stuff for like 20-30 minutes. But I decided, like, with this guy, because he has like all these stories and stuff, I said, hey man, how about we just like sit down and I'll just record it for you, and then maybe we'll use like AI to like turn it into a book or something at some point. And so that's what I was doing today for like 2 hours. I just sat down with like a microphone. I used ChatGPT actually to come up with like, hey, how would I like create a book of someone's life? Like, what should I ask them? And we started with asking his childhood beginnings and stuff. It was kind of cool. Anyways, I did stumble across an unk. Yeah, there's this old lady at the gym, and she used to curl like 50 pounds at the age of 70. Dude, that's a lot. Yeah. Good for her. You can learn a lot from older people. I know older people feel kind of lonely because, bro, all your friends are dying, you know? Like, everyone you know in this world is, like, leaving. Yeah, that's awesome. You should always... I love giving opportunities for those older than us to, like, have some sense of relevance. You know, like, purpose. It's nice. Yeah. Are you going to sell this guy's autobiography? So here's the funny thing. Just because it is LA, this guy does, like, his granddaughter is married to Al Pacino. Who was also married to Mick Jagger at one point. So I'm like, oh, so this guy is like kind of connected, and like he was at his daughter was at Jeff Bezos' wedding and stuff. So he does have a decent amount of, like, it's very LA. I'm just like, okay, like somehow you're related to like all these big fancy famous like movie director people. And he's like, yeah, you could turn this into a movie. I'm like, I'm not a movie director. I'm just here trying to be a nice guy and like give you some like purpose. But maybe this is my big break, dude. Yeah, maybe this is how like we end up funding actual education, is like I get a meeting with Jeff Bezos at like a luncheon or something. I don't know. LA's it's like only in LA does this shit happen, where you're just like it's divorced from reality. You can finally get out of this teaching math crap. Yeah. Yeah, wait, actually I want to verify that. He said his daughter's name was Nora. Let me make sure. Say, who is married to Al Pacino? Well, not all caps. Well, or who not married? Who is carrying? Who is mom? Latest mom. Oh, it is Nora. Yeah, there you go. There it is. Wow. Okay, crazy. Okay, it's real. So it's Nor, not Nora. Okay, I misheard him too as well. I guess whatever. Yeah, exactly. There are some insane experiences in LA. It's just because you're in Los Angeles. Okay, unpolarized light. This is a good one. Through 3 ideal polarizing filters, the polarization axis of the first filter is oriented with the horizontal, the second is with 30 degrees, and the third has a vertical polarization axis. What percentage of light gets through the combination, and what is the polarization direction of the light that comes out of this combination? Well, the light is always polarized in the direction of the last polarizer. So in this case, since the third filter, the last filter, is vertical, the light's going to be vertically polarized. And I think, let me get like a diagram to explain this. Someone can draw something prettier than I can. Light polarizer. Yeah, this is exactly what I want. Yeah. Oh, this is super cool. Okay, cool. I like this. This is very good. I wish this image was a little bit clearer, but it's okay. Right. So light. What? Maximum. One sec. Let me fix this. It's so dumb. I got too many images on the board right now. Here, let me just delete all these. Well, no, I want to leave this. One sec. Manage files and delete the clipboard. Cool. Delete that. Okay, cool. Should be good now. There we go. Okay, cool. Here we go. All right. So light in its wild form. So for instance, you have light waves that are like moving back and forth this way, or they're moving back and forth this way, or they're moving back and forth this way. Like it's totally random and it's in all directions. Now what you can do is you can take this light and run it through a polarizer. What it does is it only the waves are like just going vertical, but this I believe is a horizontal polarizer. Because I think like that's actually a good question. Let me 1 second. Is a vertical... Okay, what direction are the gratings on a vertical polarizing filter? Okay. No. Okay, so good. Yeah, so I was wrong. This is a vertical polarizer. And then the gratings are 90 degrees to the direction of polarization. So you have waves oscillating in all sorts of random directions, up, down, left, right, fucking, I don't know, like. And then once they go through this gate or filter, it only lets waves come through that are vertical. So now your light is only vertically polarized. Now here's the cool thing. If you were then to take this vertically polarized light, which is just in one direction, and run it through another polarizer, which is in a different direction, then only some of this energy, some of this light energy is gonna travel through. If this polarizer, for instance, is horizontal, so let's say that like the gratings are this way, then you end up getting zero light makes it through. However, if it's at an angle, so let's get like, here's an example of one. Then you're going to get a percentage of it. So here, for instance, you have a bunch of random light. It goes through a vertical polarizer. So now the light is all completely vertical. If you have a polarizer which is now at an angle, then only some of this amplitude will make it through. And the light exiting this will also be in the same direction as this like slightly slanted polarizer. And then if you run it through this one, which is a horizontal polarizer, now even less of this amplitude of wave makes it through, or less power makes through, and now your new wave is horizontally polarized. So notice at the end of whatever filter, that is whatever the polarization of that filter is, that is the polarization of the light that exits. So here they say we have a first filter which is horizontal, the second one is 30 degrees from the horizontal, and the third is vertical. So let me see if I can get one here. I'm gonna say like horizontal, middle, and then vertical polarization. I'd hoping like someone had already like done this. I guess I haven't drawn a picture. I'll draw the picture then. That's okay. We'll do it. I still kind of like this part of the photo. Okay, and then let me like, yeah. Okay. So this is unpolarized. And then it's going to run through a first filter, which is oriented with the horizontal. Okay. So horizontal polarizer means it's going to have like vertical slits. Okay. So you can think about it like this. Oh, and you know, actually, I can take the picture from... Well, no, I wish I could do it. Okay, it's fine. Okay, so this is going to be my first filter. So first filter is vertical, or sorry, horizontal. Now, the equation for the amount of light that makes it through a polarizing filter, I think has something to do with like sine squared. Let me see. What do they want again? Percent of light. Say percent of light through polarizer. Where is it? Yes. It's I1 cosine squared theta. I'm taking physics 3 this fall, so what polarization does is changes direction. Yes, but it also changes the intensity. So, let's see. I guess there is like an A. Well, I don't want the AI mode. What is this? What is this? What? Okay, here we go. So, if you have unpolarized light going through a polarizer, you already drop 50% of the amplitude. Otherwise, if you have polarized light going through another polarizer, the amount that makes it through is equal to the initial intensity times cosine squared of the angle in between the two polarizers. So I wanted like a little like graph of this. But okay, I guess we'll take this. That's okay. Well, here we go. Okay. So let's call this, for instance, like I0, okay? I1 is going to be equal to 1/2 I0. Just by the nature, if you have unpolarized light and it goes through a polarizer, I don't care what direction the polarizer is, you instantly drop half of your intensity, okay? And now your light is horizontally polarized, okay? So now it's horizontal. And what they'll sometimes do is they'll draw this on like a phase diagram, like this, and then they would say this is what you got. Okay. Now it goes through a second one with a polarization axis 30 degrees from the horizontal. Okay. So 30 degrees from the horizontal means now you have a new polarizer that is skewed a little bit. Let me think how I want to do this. I think it's going to be kind of like this. I think this is what it looks like. Yeah. So, and then that's going to create waves that are this way. Okay. So we can say like this. So here, this is I1. And then I2 is going to be equal to whatever I1 was times the cosine squared of the angle in between the polarized light and the polarizer, which is 30 degrees. So cosine squared of 30 degrees. Cosine of 30 degrees is the square root of 3/2. And then if you square that, right, you get 3/4. right? Square root of 3 over 2, right? So that is equal to 3/4 I1. And let's remember that I1 is a half of I0. So this is 3/4 times 1/2 I0. So this is equal to 3/8. Okay, so we've dropped now to 3/8 of our original light that we had. Okay, and then finally it goes through another polarizer, which is vertical. So vertical polarizer, right, means that the slits are horizontal. And so now this will only let light out that is vertical. Okay? And so now we have this, which is going to be our I3. And we can say that I3 is equal to I2. And then that's going to be cosine squared. And then, right, it's the angle between this one and this one, which is now going to be 60 degrees. This angle between these two was 30. So cosine squared of 60 degrees. Well, cosine of 60 is 1/2. So squaring that's 1/4. So this is going to equal to 1/4 I2. But I2 is equal to 3/8 I0. And so now you're going to get 3/12. So sorry, no, 3/32 I0. So that's the final percentage of light that makes it through. Yeah. So very cool. Something you should notice here though, right, is that if the angle between your two polarizers is 90 degrees. So for instance, let's say this thing wasn't here and we had just horizontal light then hitting vertical light. The cosine squared of 90 is equal to 0. So in that case, no light gets passed through. All of the horizontal light here then gets canceled out by the vertical polarizer. Yeah. You can see this too. Oh, I don't have... But if you ever have like polarized sunglasses, for instance, and you look at your computer, your cell phone screen, you'll notice that as you rotate your screen and your sunglasses, at some point the screen goes completely dark. The reason for this, the reason why we have polarized sunglasses, is that light from the sun, when it reflects off the road or it reflects off the water, like when it glares, it bounces off at a certain angle, a certain polarization angle, and your sunglasses are set to 90 degrees from that polarization angle such that it eliminates the light from glare, the light from like things bouncing off of the water or bouncing off of the road. There's probably a graphic for it I can find. Yeah. So here's some pictures we'll show. It's really cool. And again, it's physics, right? This is all physics. Okay, here's some things, right? Yeah. So the waves from the sun, the light from the sun is vertical. When it bounces off of the water or bounces off of the road or something, it's then reflected off as horizontal, and that creates like glare, right? You're seeing like the sun being reflected in a surface, whether that's the road or like you're on a lake or something. And so what polarized sunglasses do is they are set such that their grating, their filter, ends up canceling out all of that glare. But it still allows in the regular light as well. So as a result, right, this is the difference. So with lenses that aren't polarized, this glare causes a lot of problems, right? You see a bunch of you know, you can't really see the iceberg and stuff. But with polarized, it eliminates that glare, and then you can see like more details on things. Yeah, try it out. If you don't fucking believe me, because yeah, I know science is weird sometimes. If you have a pair of expensive-ish, like more than $50 sunglasses, they should be polarized. Take your cell phone and start rotating the sunglasses, and you'll notice that there's some point where your sunglasses completely look dark, and that's because the polarization angle of your sunglasses is canceling out the polarization of the light coming off of your phone screen. And because of this, phone makers usually, because phone makers know people use like polarized sunglasses, they set their polarization angle to be such that it doesn't get messed up too much by the sunglasses. Yeah. Anyways, cool. Good question there. Odin Root, HHH. I appreciate it.
Well done.
Okay, cool. Let me see. Probably got some help screenshots, and then Sib, we'll do some of yours as well. Oh, this is kind of cool. More questions of matrices. So this came from Taylor Drew. Says matrices A, B, and C are given in terms of some scalars. Right? Okay, cool. And we're saying, given that A plus B is equal to C, find the values of A, B, C, and D. So these are matrices: big A, big B, big C, and then they want you to figure out little a, little b, little c. Okay. So A plus B is equal to C, so that means -2, 3, 1A plus B -1, 2, -4 has to be equal to 1C, D, 4. Okay. Adding matrices is pretty simple, right? All you do is you look at like the same positions for things. So for instance, in this case, this plus this equals this. So this is just -2 plus B is equal to 1. This is 3 minus 1 is equal to C. This is 1 plus 2 is equal to D. And then this is A minus 4 is equal to 4. So not too bad, right? From this right off the rip, you can say, okay, cool. A is equal to 8. D is equal to 3. C is equal to 2. And B must be equal to 3. Nice. That was not too bad, Taylor. What can be like? I'm amazed this wasn't like a systems of equations or something. They should have put like A here, and they should have said like, oh, if I multiply the matrices, I get this, you know, or if I subtract the matrices, I get something else. Yeah. But no, that's pretty easy. Okay. Cool. Still a good question. Bum, 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 bum. Yeah, you're welcome. Nice.
Well done. Well done.
Okay, cool. All right, let's see. Sib, you got a hard one for me, all right? Oh. Am I natty? Yes. You know, it's so funny, HHH. I was actually like talking to my one friend that I work out with at the gym, cuz I don't take like pre-workout. I don't take BCAAs. I don't take creatine. I don't take I mean, I do occasionally like eat some protein powder just because I'm lazy, but I just eat bacon and chicken and beef. And my body just like naturally wants to like get bigger. Yeah. I know that's a big debate these days. Are you natty or what? Because all these kids on Instagram, did you see where they're taking Plan B pills to intentionally crash their testosterone levels and then get prescribed like testosterone by like a doctor because they're like, oh, your levels are low? That's like so dumb. People will try a lot of things. I don't know. And the internet, for all its beauty in like sharing information, also sometimes shares like some really bad information. No. Yeah. But yes, no. I probably should start taking creatine. Apparently it's like good for you. But yeah, I'm honestly, I'm just lazy. I just don't have time to remember to take supplements. Yeah, it's insane, right? Trust me, I'm a pure carnivore. Yeah, I just eat a lot of meat. I love eating bacon. I love eggs. I love cheese. I love chicken. I love shrimp. I just like eating animals. I know that's like not some people's vibes, you know, but it's okay. Teach their own. All right, let's see. Let epsilon be the region inside the sphere. Okay, so this is a sphere. So we know that is radius 2. Odin says, I only take creatine. I just turned 19. There's a dude my age that's always been taking Monster and energy drink. Yeah, I mean, that's just really caffeine. Just, yeah, don't. I see the temptations of like some of these some of these kids, because they're not my students, doing like fucking Tren and stuff, or I don't know. I don't even know what the names are, but they all sound like bad things. Yeah, don't just go to the gym. You don't need to like mess with your hormones, especially when you're 19. What's up, Hunter? Hunter likes, I once shot a wild hog and ate it. Nice. You know, in Texas they do hog hunts, like, but from helicopters and with like ARs, like assault rifles. It's because like hogs apparently are like a big problem in Texas. They like destroy the landscape. They kill the ecosystem. They just like, they're just not good for the environment, and like they don't have any natural predators anymore. So now they have these tours where yeah, you can go up in a helicopter and like shoot them with like night vision goggles and stuff. It's very Texas. But anyways, this is a sphere of radius 2, and then it shifted down, or shifted up. Shifted up to the z-axis. Ain't no helicopter, yeah. It's not cheap for the helicopter, obviously. Okay. Above the cone. Okay. In the third XY quadrant. Okay, for X and Y are greater than or equal to 0. Let's try to like draw this, man. Like, what's going on? Okay. So third XY quadrant means eventually they're just looking at this, right? But okay, so we have a sphere. We'll draw the sphere in red. And it shifted up too, so it's kind of a weird sphere. Right? It starts to come down a little bit, actually. I didn't draw that right. Charge density volume? Yeah, it could be that. Okay, I think this is like the best I'm gonna get with like trying to like draw my sphere. Okay. But then it's above a cone with, okay, so then you have this. Z is equal to x squared plus y squared. Oh, it's an inverted cone. Sorry, it's like, because you see how like x squared plus y squared gets bigger as z gets bigger. Oh, man. Okay. Okay, so it's like this. Okay, I think it's something like that. And then hopefully, because it's shifted up, the cone doesn't ever, like, intersect the sides of the sphere. It might, though. Okay. And then in the third XY quadrant, so... Z is greater. Oh, wait. So, wait. We don't count here? Fuck. Okay. Okay. So, I think they're talking about, like, this region up here. But then, we just want it in this region, so it's, like, just right here. Okay. Alright. Prepare to calculate the following integral in spherical coordinates. I like spherical coordinates, at least. Noting that the sphere has the equation x squared plus y squared plus z squared equals 4z might be helpful. If you're a clever clogs... What? Is that actually a word? Clever clogs? Excuse me? I want to be a clever clogs. Oh, you're also taking this? Yeah, this is multivariable for sure. Oh, it's British? Where is Sensation? Do I gotta go out and hunt for Sensation, dude? Where's Sensation? You do not need to worry about the undefinedness of the function along the z-axis. Okay. Clever clogs is British English slang term used to describe someone who is perceived as being intelligent or knowledgeable, but in a way that is considered annoying or pretentious. So, dude, I love how snarky they are with this question, dude. They say, if you're a clever clogs and you think about such things, like just in my spare time, am I just daydreaming about cones inside spheres? I mean, I guess maybe that's the type of stuff you're into. Shaking my head, yeah. I've definitely heard of Clanker, dude. Clanker came from Star Wars. That's from the Clone Wars. That's like before some of you guys were born. But it is making a comeback right now to refer to like the AI stuff. Yeah, like clankers. People just love like the hard R's on words. There was a cool like a speech guy, like a language guy, talking about like why certain words are preferred to be like derogatory slurs and stuff. It's because like they have like certain sounds to them. So yeah, clanker kind of fits it. Tin-skinned and wireback. Alright, so wireback is a play on the Mexican derogatory one, I guess. I don't know what tin-skinned is. Okay. Let's look up spherical coordinates again so I can just remember. Also, we have to be careful to do it in math. Spherical coordinates are different in math and physics. Oh, thin-skinned. Yeah. I think I gotta tell TikTok I'm still doing stuff. School is starting for some high school students. I know it is for sure. In math, we correctly measure from the XY plane. Yeah, physics measures from the Z-axis. Wait. Is that not what's happening here, though? Dog? Wait a minute. Wait a minute. Wait a minute. I'm confused now. Wait, what? Okay, now math just seems goofy, dude. So they just changed theta and phi. Fascinating. Yeah, but you don't measure it from the... Look. I mean, that's two different sources, though. I thought it was from the XY plane, too. Apparently not. Yeah, apparently it's from the Z-axis. I just can't care. I just can't wrap my head around why we care about switching. Seems kind of random. You're talking about like why do we switch to spherical coordinates versus doing things in Cartesian? The reason being, well, there's a couple of reasons. So one of the first reasons is that this stuff here goes away if we start using spherical coordinates. So for instance, in spherical coordinates, x squared plus y squared plus z squared is equal to r squared. So when you have something like this instantly just gets reduced to an r squared. And then square root of r squared is just r, right? And the other thing is, let me get all the coordinates. In real life, how can we do that as a model? Yeah, because some things do in real life like depend on this. But so for instance here, with this integral here, x squared plus y squared, so x is equal to r cosine theta sine phi, y is equal to r sine theta sine phi. So when you do x squared plus y squared, that ends up equaling rho, we just say r squared cosine squared theta sine squared phi plus r squared sine squared theta sine squared phi. And now you can group by this. So you end up getting r squared sine squared phi, and then it's cosine squared plus sine squared. But cosine squared plus sine squared is 1. So then just this equals r squared sine squared phi, which is nice, right? Because here, the square root's gonna like kill off all the squaring, and then this is gonna kill off this to just become an r. Yeah, the reason why we change coordinate systems, usually due to like some sort of symmetry. This is a sphere, and a cone is also like kind of spherical in terms of symmetry. So you want to work in that coordinate system anyways. But you also look at what you're integrating. And if what you're integrating has a bunch of square roots and a bunch of x squared plus y squareds, it's going to make it look a lot easier anyways. In real life, why does this come up? Because these kind of this represents the magnitude distance of something in the xy plane. And then this is something the magnitude distance in the xyz, like whole volumetric space. So some things depend on how far away you are from, let's say, the z-axis, which is this basically, and then some things depend on how far away you are from the origin. if you have like an infinite line of charge, right? You remember how like electric field only depends on like the distance r away? That's represented in this. Yeah. Okay. So to calculate this one, let's just try to make sense of it, right? I think with integrating, you want to take as your outer integral for volumetric stuff. You want this to be like, I'm trying to describe what I think about it. Like, this is like the easiest to see and doesn't vary really. So, for instance, when we're looking at our coordinate system here, I know that I'm restricted to this quadrant, okay? Restricting to this quadrant is like the biggest and like most overarching filter. And that restricts theta to be from like pi over 2 to 3 pi over 2. So, and that doesn't depend on radius. It doesn't depend on phi. Like, I don't care. You're only allowed to have things with thetas between pi and 3 pi over 2. So I would write my first integral, which is really your outside integral. It's really your last integral, which would be d theta, right? I would write that as going from pi to 3 pi over 2. Because then that covers only this quadrant. Okay, now we got to think about, if I'm only in this quadrant, what are my other restrictions? Well, I see a restriction in phi already, right? Do you see how phi can only go from here to here? Right, phi is the angle away from the z-axis. So if I'm above this cone, right, not outside the cone, then the angle I can make from the z-axis can only go from 0 to pi over 4. So I'm going to make that my next, like, my next restriction. I'm going to say this is like 0 to pi over 4. And this is, again, one of these things where, like, is this methodical? Is there, like, a plug-in, you know, mechanical way to do this? I don't really think so. I think you have to kind of build an intuition, again, by doing problems, in order to kind of see which is, like, the simplest integral to do first, and then as you go in. Okay, so if we've then restricted here from 0 to pi over 4, we got to think about what r is going to be. Okay, this is where r is going to be a little weird, right? Well, we know that the radius needs to be above this. And that's going to change based on, like... okay. Yeah, wait. That comes from this. Yeah. Z is greater than or equal to x squared plus y squared. Okay, so let's write this out, right? So Z has to be greater than or equal to x squared plus y squared. But x squared plus y squared is r squared sine phi. What's the importance of this in real life? Yeah, like I was describing, a lot of things in electrodynamics refer to like spherically symmetric things, like point charges or line charges. These all kind of come up. Right, yeah, it's just the top charge, right? And so above the cone means Z has to be greater than this, okay? So now Z has to be greater than r squared over sine squared phi. Z is equal to r cosine phi. So we know that r cosine phi has to be greater than or equal to sine squared phi. Okay. I wonder if I can, like, divide some stuff here. So that goes away. That goes away. So I get cosine of phi. It has to be greater than or equal to r sine squared phi. Oh, sorry. Z is greater than r. Sorry. It's the square root of x squared plus y squared. Oh, okay. Oh, well, actually, this doesn't help me at all. Uh-oh. This kind of fucks me up, actually. Oh, I actually don't like this. Oh. Because now I get that, oh, this is just dumb, right? 1 is less than or equal to sine or tangent of phi. Does that help me out? I don't really think it does. Fuck. Yeah, but don't worry about what this is. Don't worry about this. We are just trying to describe the space in spherical coordinates. And so if I'm talking about something in the third quadrant, that means that theta has to be from pi to 3 pi over 2. And then if I'm describing something above the cone, okay, then it can't be here, right? It has to be on the inside. And that's going to be having a phi going from 0 to pi over 4. So that's why we have this part of the integral, the next one. Where I'm getting kind of stumbled on is, what do I want my z to be? Or what do I... No, well, sorry, I need dr. I need dr. They say it's 0 to 4 cosine phi. Why is that? I don't believe r can be 0. Can it? Above the cone, z is greater... Oh. Oh. Wait, Sib. I think it's inside the cone. So the cone is hollow, right? So I think technically this works as well. Like this area works, and then this area works. Okay. Like as you go around x and y, as you're like integrating, yeah. It's inside the sphere, it's above the cone. So it's like the ice cream in the cone. So that's why r can start at 0. But then as you start... Yeah, I see how this works. Oh, this is so wacky. Okay. Okay, I understand now why it goes from 0. But then let's see where it goes up to here, right? So they're saying, as I integrate in theta, so as I go around in this coordinate plane, and let's say I pick a certain angle. Let's say I pick like right like this angle, okay? I now need to integrate this way in terms of phi. And then once I pick that phi, I need to go all the way from 0, being r, all the way up to here. Oh, fascinating. So I need to go from here to the edge of the sphere. Yes. Okay. It's not just the top area of this. Okay. This is the equation for the sphere, which, yes, if you expand this out, Sib, right? So this becomes x squared plus y squared plus z squared is less than or equal to... So you're going to get a plus 4. Here, this is going to be z squared minus 2z plus 4 is greater than or equal to 4, less than or equal to 4. This goes away. So you get that this is less than 2z. Very cool. Okay. So x squared plus y squared plus z squared has to be less than or equal to 2z. And then remember, x squared plus y squared is the same thing as r squared sine phi. Yeah, r squared sine squared phi. Z, it's gonna be r squared cosine squared phi. And then this is 2r cosine phi. Just for like how you define z in spherical coordinates. Right? Z coordinate here is r cosine phi. And then x and y is like some combination of the cosine phi and the sine theta and stuff. Okay. This is cool. This is the same thing as r squared times sine squared phi plus cosine squared phi, which is equal to 1. 2r cosine phi. Okay, very cool. So watch this. Divide by r. R is less than or equal to 2 cosine phi. Now, did I fuck up? I did fuck up. Because this should have been 4z, not 2z. It is. Yeah. Yeah, I forgot to multiply by 2 again. So this is 4. This is 4. This is 4. Okay, cool. There you go. That's why the integral is from 0 to 4 cosine phi. Oh, man, that's fascinating. Okay, cool. And then, yeah, when you go to spherical coordinates, it's, I think you have to change dv. So one sec. So dv in spherical. Yeah, this is it. It's a cool question, Sib. Yeah. So you have to add some other things here. So it has to be r squared sine phi. That's just for the dv. So dv in Cartesian, Sib, this is just equal to dx, dy, dz. But when you go to other coordinate systems, you have to do something which is called the Jacobian to like figure out how volume is integrated. And it turns out there's an extra r squared sine phi term on it, and then it's dr d phi d theta. If you want to verify this is correct, you can do this for just a solid sphere, and you'll see that you get you'll get 4/3 pi r cubed. It's actually pretty cool. I can show it. Do you know how to integrate in spherical? You don't? Okay, let me show it to you real quick. So, you know, right? Let's say I wanted to just integrate like a square. Here, this will be a good primer for you guys watching. That this is a little bit more basic. We're gonna just do 2D integration. Okay. So, yeah, exactly. Yeah, so watch. So if I wanted to integrate this, okay, like this amount of area here, I could think about this as going from like, let's make this x, let's make this y, and then let's have this go from like a, and then let's make this b. Okay, you could write this as two integrals, a double integral, if you wanted like the surface area of this, right? This would be the integral from 0 to a dx, and then from 0 to b dy of just one. Pure mathematics is beautiful because it's not applied. It happens sometimes, Motion. Okay, but watch what happens. So when you integrate just one dx, you just get x, right? So then that becomes 0 to b of just x evaluated from 0 to a dy. And then this is just going to be a minus 0, so it's just going to be a. So then you have the integral from 0 to b of a dy. Integrate this. You're going to get ay from 0 to b, which is going to just equal to ab. Yes. This right here, right, is just the area of a square, right? Width times height, a times b. That's where that comes from. Okay. Extend this out now to a cube. Let's go up to 3D. Okay. So let's say I don't know, something like this. Did I do the volume? No, that was the area. I'm about to do volume. AB was the volume of the shape? How can it be the volume? Oh. Wait, what? Yes. Oh, I see what they're saying. Okay. Yes, my bad. Sorry. Thank you. Yes. Yes. Thank you. 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 Yeah. Yeah, I just wanted to do dx dy. I get it. I get it. I set my z just equal to height 1. Okay. Maybe I think this is what I actually wanted to show. I was confused there for a second because I'm like, wait, I actually only need like one integral to get area, right? Don't I? Yeah. Okay, let's say it's not height 1. Let's say this thing has a height c, a width a here, and I don't know, like a length b. Right. Okay, cool. Let's just do it. Let's just see what happens. So this would be some integral dv, which in Cartesian is dx, dy, dz. So let's see. So in terms of z, we're going from 0 to c. And then in terms of y, we're going from negative b over 2 to b over 2. And then in terms of x, we're going from 0 to a. Okay, let's say this is y-axis, this is x-axis, this is the z-axis. I'm going to say like this length here is b, this length is c, this length is a. Polar might be a good starting point. Yeah, I think I just want to show this and then... You're right, I could do that. I could do r dr d theta. Let me show that next then. Okay, so if you were to integrate this, integral dx is just x, and then x from 0 to a is just going to get you a. What's up, equity? So then you get a dy dz. So if I integrate this, now I'm going to get b over 2 minus b over 2. So that's just going to equal to b. So now you have a, b, dz, and then do another integral. You're going to get abc. And that is the same thing as the volume of a rectangular prism. Okay, this is all done in Cartesian. Let's do things in polar, which I kind of do like. I like what Jeff was implying there. Okay. So if you wanted to integrate this in terms of Cartesian, this is kind of a mess, right? So a nicer way to do this would be to think about, okay, let's consider that instead of, you know, going over an x and then like integrating in y, which is like the square root of 1 minus x squared or whatever, I could think about taking like a circle. I can think about things in terms of like r and theta. Okay, where I'm gonna do integral here. Join my fan club. What did that come from? I don't have a fan club. Oh. Yes. Okay. Watch. Yeah. Okay. Sorry. I'm not gonna do volume yet. I'm just gonna do area. The gold club. Yes. The other way to do this is to do this as RD theta. Where does this come from again, Jeff? I think this is what you do. You are going to do a double integral. You're going to do a double integral from 0 to r, and then theta is going to go from 0 to 2 pi, right? So, like, I'm going to integrate, and then, is it RD theta? I think this is now the new... It makes a little rectangle-y thing, yeah. Okay, but I think when I integrate this, though, right? So, integrating from 0 to r... Oh, sorry, yeah, thank you. It's r d theta. Yeah. Right. When you integrate this part, you get r squared over 2 from 0 to r. So, like, cool, whatever, that's just r. Like the Gaussian integral. Yeah, exactly. And so now when you integrate this, you get r squared over 2 theta from 0 to 2 pi, which is going to get you pi r squared. Yeah, sorry, there's no dr here anymore. Sorry. Yeah. Yeah, you're right. Okay, and then this is the area of a circle. So notice here, right, that instead of doing just dA, my dA now became RD theta. If you do dA in Cartesian, I guess it's just dy, right? Isn't it? Okay. In spherical, let's do spherical real quick. Spherical is cool. Cartesian is dx dy. Yeah, but wait, Jeff, I was doing that here. And someone was explaining to me that, like, oh, you found the volume of a cube of height 1. Someone in my chat was saying that. When you integrate the number 1, you get area. Same thing, though. Yeah. Yeah, I agree this is the volume of something of height 1, but also this is also the area, right? Isn't it? Aren't I isn't this a calculation of area? Yeah, okay, cool. I'm not crazy. Oh. I think I remember why now. Yes. Yes. Because, okay, when you do a regular integral to find area, you're going from 0 to a dx but then you're integrating from 0 to f of x dy. This is like what happens, right? And this is why this becomes the integral from 0 to a f of x dx. Is how you figure out the area of this. Oh, okay, cool. So I was right. Okay. Starting to lose my mind about why. Someone was telling me that this was a volume integral. I'm like, no. It's two integrals. It means it's an area. Exactly. You could do it with the circle as well. Okay, let's do it with Cartesian, though. Okay. So, yes, exactly right. Yeah. Okay. So, Sib, if you're trying to figure out the area, the volume of a sphere, okay? So we did the area of a circle. Oh, no, this is okay. I mean, this is a good refresher for anybody else who's like looking at this, because it's kind of like a basic thing, but it's good. Okay, this would also be a triple integral, okay? Which dv, this could be expressed as like dx, dy, dz, but then it becomes a real mess to describe what your bounds are on x, y, and z as you try to integrate over this like curved surface, which is Jeff's favorite. Jeff loves spherical surfaces. So the easy way to do this is to do dv in spherical coordinates, and dv in spherical coordinates is this. Here, I'm just gonna copy it real quick. I just don't have to draw it. This is now spherical coordinates. So this whole thing here, this is now equal to dv. And okay, so for our bounds, right? So phi, which describes the angle from the z-axis, that's going to go from 0 all the way down to pi over 2. Then theta is going to whip around like horizontally. And that's going to go from 0 all the way back to 2 pi. And then r will go from 0 radius out to like wherever out it is. Yeah, exactly. Yes, exactly. Yeah. Except we did surface area there, I think. This is volume. So when you integrate this, you end up getting like, so the integral of r squared is r to the third over 3, and you're going from 0 to r. So this just becomes r cubed 3 over 3, and then this is sine theta, d theta d phi, and now you're integrating d theta. Well, d theta is just going to pop out a theta. Okay. Which, going from 0 to 2 pi, is just going to get you this. And now finally, integrating sine phi d phi is going to get you negative cosine, right? Wait, derivative. No, it should give you negative cosine, right? Oh, wait. I don't want my volume to be negative, though. What? Excuse me? Help, Jeff. Isn't the integral of sine negative cosine? Oh, it's negative for the integral? That's ugly. Oh, okay. And then cosine of...
Oh. Yes. Oh, no. No, it works. It works. It works. Watch what happens. So you get r cubed over 3, 2 pi. And then it's negative cosine of phi. But then it's evaluated from 0 to pi over 2. Yes, exactly. So when you plug this in, cosine of pi over 2 is 0. But then it's minus. That's where the plus comes out. And it's just 1.
Wait. Yeah, wait. Cosine of pi over 2 is 0. Which is 1. Oh, I need a 4 in there, though, dog. Where's my 4? Where'd my 4 go? Oh, yeah. Okay, so this is 2/3 pi r cubed. Yes. That's for the top half. Yes, that's only... Okay. If I'd set my phi to go from negative pi over 2 to pi over 2, that would have been the whole volume. And that would give you 4/3 pi r cubed. Aha! Okay, see, I'm remembering things too. There we go. And that's the volume of a cube. But the key thing here is when doing volume integrals in spherical, you need to use this special thing. Which, again, I think comes from the Jacobian, is what it's called. Okay, so let's try to, like, just do this integral real quick. So, I don't know why they're splitting it up all weird like that. But, okay, we had this. And then let's look at what things here. All right, so x is the same thing as r cosine theta sine phi. So this was our dv term. Let's put this way over here. So x is r cosine theta sine phi. And then we already figured out that square root of x squared plus y squared is equal to r sine phi. Oh, so watch what happens. So this is over r sine phi. And then this thing here, right, was just r. Okay? And then we have another r squared from our dv. So this right here, this was our function. And then this right here was dv. Where this right here is... This is like f. This was f of x, y, z. And then we used our switch of coordinates to get to this. This is really nice. Because look at this, right? R times r over r squared. This all goes away. Love this. Bing, bing, bing. Goodbye. Sine theta over sine phi cancels. So then you have a really nice... You have a much nicer integral to deal with here. So we just have... Exactly. It's r cosine theta sine phi. Bro looks dumb, but shit looks hard. It's not that bad. D phi d theta. Okay. So if you integrate cosine, we already found out, right? That's negative sine. This is integrals in 3 dimensions. It's vector calculus. So let's see. So integrating. Wait. I want to integrate dr first. Sorry, my bad. So that's going to be r squared over 2. Cosine theta sine phi. D phi d theta. And then this is evaluated from 0 to 4 cosine phi. Okay, cool. So... Dude, I dropped out. I'm escaping school, dude. This is escaping the Matrix, bro. Okay. So if you plug this in, you get 16 cosine squared phi over 2. So that's 8 cosine squared phi times the sine phi. Okay. So you have 8 sine phi, and then that's going to be cosine squared phi. Okay. Doing d phi. This is the same thing as u du. See how this is like u squared negative du, I guess, is a minus sign. Yeah. So then that becomes, so the integral of u squared, negative u squared du is going to become u to the third over 3. So now you have 8 cosine theta. There's a minus sign now out front. And then this is u to the third. U is cosine. So it's cosine to the third phi from 0 to pi over 4. Cosine of pi over 4 is equal to square root of 2 over 2. So cubing that, you get, so whatever, to the third you get 2 square root of 2 over 8, which is the square root of 2 over 4. Okay. And then it's minus cosine of 0. Okay. Cosine of 0 is just 1. Okay. dv isn't equal to phi squared. No, I think dv is r squared sine phi dr d theta d phi. Did I fuck that up? No. Yeah, look, no, dv is r squared sine phi dr d theta d phi. Yeah. Okay, so then this is going to be square root of 2 over 4 minus 1. Oh, and we already did this one. Okay, cool. And now we're just left with d theta. And the integral of cosine is negative sine. Uh-huh. Okay, cool. So the negative's going to go away. So we just get 8 sine theta square root of 2 over 4 minus 1 evaluated from pi to 3 pi over 2. So sine of 3 pi over 2 is negative 1. Sine of pi is 0. Okay, so I have 8 times negative 1 times square root of 2 over 4 minus 1. So what is that? Multiply the 8 through, you get... here, I'm going to have the minus sign, like, switch that. I have 8 minus 8 over 4 root 2. 8 minus 2 root 2. Is that the answer? 8/3? Fuck. Where'd they get the 3 from? Oh, my bad. I forgot about this 3 here. Sorry, there's a negative 1/3. Okay, cool. So it's 1/3 8 minus 2 root 2. Is that the same thing as this? Okay, one sec. That's 1/3 8 minus 4 over root 2, which is root 2 over 2. Wait, sorry. 4 over root 2. Root 2 over 2. Oh yeah, 8 minus 2 root 2. So I think it's what we got, yeah? Oh, it is. Nice. We did it. Woo. Hot damn. That's a cool question, Sib. Yeah, you're very welcome. What a mess. But I like it. Okay, cool. What's up, Equity? Equity, you hanging around? Now cylindrical coordinates. Make it slightly tougher. All right, let's do yours. What do they want us to do with this, Equity? Equita. I see a matrix. Yes. They want us to find the inverse of this? Wow. Okay. The way to find the inverse of these matrices is to augment them. So, yeah, Gaussian elimination, yeah. But it's a pain in the ass to deal with. So you have like 1, 6, 3, minus 3. And then you do like 1, 0, 0, 0. And then this is like 2, 7, 1, 2, 0, 1, 0, 1. Or sorry, 0. 1, 5, 3, minus 3, 0, 0, 1, 0. And then 0, minus 6, minus 2, 3, 0, 0, 0, 1. This is like technically what you create. Okay? And then your goal is to turn this into this. And then when you do it, when you turn this into this, whatever's left here is your inverse. Exactly, Motion. Does your teacher just like hate you? Like, are you supposed to find this by hand? It's a huge bitch. What's up, Zach? Well, they asked him to find the inverse of this matrix, which this is really terrible, isn't it, Zach? Shout out to Zach. Zach's a great guy. What's up, Meeson? I had one of those on a final exam for my linear algebra class in undergraduate. Really? Okay. I can tell you the process. I'm not going to do it because it would take forever. Ooh, Zach, does something just look... does it look really nice? Yeah. So... Yeah, you have to do row operations to turn this into an identity matrix, which, for instance, you know, you'd have to, okay, so R1 minus R2 minus R3 is now equal to R3, okay? So let's see what that would become, right? So R1 minus R3 becomes R3, so 1 minus 1, this becomes 0, this becomes 1, this becomes 0. Oh! Yo, look at this already, Zach. That's actually kind of fucking nice. Okay, but then you have to do this minus this. Okay, so 1 minus 0. So this is now 1. 0 minus 0 is 0. 0 minus 1 is now negative 1. And then 0 minus 0 is 0. Okay. So then another row operation would be negative 2 times R1 plus R2 gets you R2. Okay. So negative 2 plus 2, 0. Negative 12 plus 7, negative 5. Negative 6 plus 1, negative 5. 6 plus 2, 8. Negative 2 times 1 plus this. This is now negative 2. This is still 1. 0, 0, 0. Okay, cool. Okay. It is. Look at this, Zach, right? Now R1 plus R4 implies R1. So adding this to this now becomes 0. This becomes 1. This becomes 0. Adding this to this now just changes to a 1. This is a 0. Okay. I see another one, right? Did I fuck something up? Wait, did I fuck something up, guys? I'm sorry. One sec. From here. R1 plus R4 equals R1, right? 1 plus 0 is 1. 6, 0. 3, 2, 0. You can't have a row of zeros. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 1 is 1. Oh. Yeah, sorry, I did that backwards. Yeah, sorry. Sorry. Implies R1, doesn't imply R4. Thank you. Okay. Yeah, okay. Yeah, the last one I did. This is why these are tricky. Now, here's a really cool thing. Watch. If I add -1 of this to this... So here's what we're doing. We're snaking down this way. Actually, I think we were supposed to do like this. I think I fucked up. But I'm just we can always switch rows later if we want. But if I do negative R4 plus R2 equals R2, use a different color actually, sorry. Negative R4 plus R2 now implies R2. Watch what happens. Yeah, it's not like required, I know. Okay, so negative 6, negative 6, which is 6. 6 minus 5 is 1. 2 minus 5 is negative 3. Negative 3 plus 8 is 5. What's the difference between you and a light bulb? I don't know. Is it something where like something gets screwed or something? This plus -2 is that. Blah, blah, blah. This is the only one that changes. -1, so this is just going to become -1. Okay. I think we're close though, gents. No? I get a feeling like this and this are gonna cancel out somehow. Yeah. You have to keep going though. It's gonna be hard. Wait, sorry, Pope, what are you saying, dog? The light bulb can be replaced. Aww. Thank you, QSM. That's really nice of you to say that, man. What's the difference between you and a light bulb? The light bulb can be replaced. Why does a right-hand rule when trying to figure out which way a magnetic field is going? Why can't the field go the opposite direction? Because that's just how cross products work. Yeah. It's just, yeah, like, the field is a vector moving up. Yeah, but fields have, like, there's a convention, like, if charge is moving up or down. Or, like current, right, is technically negative particles moving to the left or something. Where does it get the left-hand force? We're talking about left-hand force. Are you talking about F equals QVB? Anyways, equity, you just have to keep doing this. I got you this far. Just yeah, keep going for it. It's a mess. It actually worked out pretty nicely up to here. Can I send you the work? Yeah, I can send it to you. What is this for, by the way? Is this your class? Why does the positive go to the left? I'm not sure I'm not sure I follow what you're saying. I know the right-hand rule, yes. Where you put your thumb up, correct. So if you have current that's going this direction, by the right-hand rule, that creates a magnetic field that does this, right? Why can't it go the other direction? It goes counterclockwise. That's just the definition of what it does. Are you asking why does the magnetic field not go this? I mean, the magnetic field can go that way if you pointed the current in the other direction. If the current's going down, then you can have the magnetic field go clockwise. Yeah. Why does it go clockwise when it goes up? No, it goes counterclockwise when it goes up. Why can't it go the other way when going up? I mean, it's just definition. It's just how a cross product works. Because, I don't know, like, curl B it's because of this. Like, the curl of B is equal to mu naught I. So, it can only go in one direction. Can't go in both. This is a cross product. This is where the right-hand rule comes from. If you want to like look into it, That's all this stuff. That trick you do with your finger and your thumb and curling, it's a hack. If you really want to do the proper form of this, you should look at like how math works with cross products. Yes, it's Ampere's law with a differential. Where's the B vector coming from? That's the curl of the magnetic field. That measures like how much something like spins around something. How does an electric field going up make a vector going to the left like that? By Ampere's law. Here, if you want to look, yeah. B dot dl is mu dot I. I want the Maxwell, sorry. I think it's Maxwell's equations. Here you go. There you go. No, Ampere's law is, yeah, the two wires are attracted to each other. That has to do with QVB. That's a different thing. That's because the magnetic field created by one wire creates a force on a... Anytime a current is in the presence of a magnetic field, there's a QVB force that pulls it in the direction of QV cross B. Yeah, but this is what I was talking about. What's Ampere's circuital law showing then? I don't know. Well, you're saying a bunch of things here. Oh. Yeah. Pope, because it has to run in a direction. It can't run in two directions at the same time. So you have to come up with a convention for which way the direction runs. Yeah. Okay. I've already explained it to you. It's because of this. It's because of cross products. That's why it doesn't go in the opposite direction. It's like, you know, what? Okay. Well, it's because that's how it is. Like, it's binary. It's binary. It can either be one thing or the other. It can't be both at the same time. You know? It's either yes or no. It's either left or right. And whether it's left or right depends on your sign convention and like what you have a cross product being. Why can't it be the other? It can't be both at the same time. It's because that's the convention we have for cross products. Yeah. Okay. Nick, where you at? Nick, I'll do your question. I gotta go in the next 10 minutes. Sorry. We'll be on tomorrow, though. If you guys want to come check us out tomorrow, we're gonna be streaming again. I'm more than happy to, like, go through more things again. I'm under, like, some time restraints, getting ready for Burning Man. But... yes, magnetic field does represent a force. It represents a force on a current.
You.
What's up, Nick? Here's what you should check. This is another thing. Pope. So, force, if you have charges in an electric field, there's a force, and that's equal to the direction of the electric field. If you have moving charges, QV, moving charges is what creates a current, right? Current is moving charge. Then the velocity of that
charge, QV, crossed with B, gives the force. And that's only one direction. It can't go in two directions at the same time. Yeah. Love Jesus Christ forever. Yeah, that's a bad X. That should be a cross product. Yeah. Okay. you want, here, I'm gonna dump this in the chat. But there's our
schedule. We will stream tomorrow if you want to see it. Okay. Nick, which one you want me to go over?
The newer ones that I sent.
The newer ones you sent. Okay.
Yeah. After what I wrote, the new stuff I found after that.
Okay. What did we do? Alright, I'll do these two. Then I gotta go. Yes, One Direction, correct. Okay. I love this first question. Suppose you were called to give first aid to several victims of an accident. First attention should be... Dude, how is this a question you actually have to solve? Dude, what? Bleeding severely, unconscious, groaning loudly, or vomiting?
Oh yeah, I wanted to send you that from... That's the exact same question from Trackman.
Yeah. I believe it's this, yeah. Okay, cool. All right, whatever. If an officer's weekly salary is increased from 480 to 540, the percent increase. All right, do you know how to calculate percent increase?
540 minus 480 divided by 480.
Yeah.
Times 100.
Easy. So what's that? That's 60 over 480, which is 6 over 48. So that's 1/8. Which is equal to like 0.125, and then times 100, that's 12.5. Yeah, good. All right, I'll do a couple more. Those are easy. And then I gotta go. Okay, suppose that 1/2. Sorry, let me make sure I'm not missing any text from these people. Okay, cool. All right, suppose that 1/2 the officers in a department have served more than 10 years and 1/3 have served for more than 15 years. What fraction of officers have served between 10 and 15? Okay. This was a similar question.
Yeah. They're all the same.
Okay. So this is 10 years, and you have a half, right? And then 1/3 have served more than 15. So let's do a different arrow here. This is 1/3. So between 10 and 15 is here. So that's going to be the whole 1/2 minus 1/3. So that's 1/2 minus 1/3. That's 3 over 6 minus 2 over 6. 1 over 6. Choice C. Cool. In a city prison, there are 4 floors. The top floor houses a quarter. The bottom floor houses 1/6. One-third are housed on the second floor. The rest of the floors are housed on... Okay, I see. There are 90 on the 3rd floor. So we say 90 people. Total inmates. Okay, so... You know all of these have to add up to 100%. So a quarter plus a third plus a sixth have to equal 1. So then 3 over 12 plus 4 over 12 plus 2 over 12 has to equal 1. So 9 over 12. Oh, plus x. Sorry. Oh, so that means this is 3 over 12. Which is 1/4, I guess, yeah. That doesn't make any sense. Sorry, 1 sec. 1/4. 3 over 12 plus 4 over 12. Oh, that's 7 over 12. Yeah, 7 over 12. 9 over 12. 3 over 12. 1/4. Oh, I guess a third plus a sixth is a half. Yeah, okay, cool. So 1/4 is equal to 90 over the total. So that means total equals 360. Reality doesn't have to have an explanation. Yeah. Eventually, at some point, Pope, you just have to ask, like, why? Why is why? Yeah. Science requires us to at least, like, make some, you know, assumptions why things are the way they are. Otherwise, we can't, like, build up and figure out more complex things. It's good to ask, like, the underlying questions of, like, well, why is that? You know, what's the... But if you really want to, like, dig deep down into that, you're eventually going to have to get into, like, subatomic particles and, like, quantum shit, which is not helpful when you're trying to understand, you know, what's the force on a wire or how does, like, a DC motor work. So I applaud you wanting to learn more, but at some point, you have to just trust and just believe certain, like, basic fucking things, right? If we start, like, going into, like, why is 1 + 1 = 2, then you could never do calculus. You know, there has to be some point where, like, you're like okay with it. Okay, cool. Good question, Nick. Okay, Motion, I wanted to do your question, but I gotta go meet someone. Sorry, in 5 minutes. But I appreciate you being on stream. Thank you, Motion. Let's close it out. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate it. Thanks for all your support. Thanks for the questions. Thanks for the activity, the vibes, jibes, all the great stuff. Our next stream will be tomorrow. That's at 5 p.m. Pacific, 6 p.m. Central. So 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by. You're very welcome. Let's go raid someone. Who am I gonna go raid today? Bum, 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 bum. Dun, dun.
Hey.
Not many people are, like, doing stuff these days, man. What happened to all the science streamers?
Where's that Galaxy river?
Galaxy chick? Yeah. What do you mean Galaxy? Sorry.
Galaxy guy, the one that some from NASA or something.
Oh, Nerduino. Yeah, Nerduino's dope. We like Nerduino. Astro's Pori, what's he doing here? I guess he's doing Legos. He looks like he does astronomy stuff. Okay, whatever. Fuck it. I don't care. Okay, you're welcome. All right. Enjoy the rest of your Tuesday. We'll see you tomorrow.
Bye.
Peace.